what we decided to do, since there's so much of a shift from, obviously we can't meet up in person anymore. What we've had to do is we've had to put a lot of things online, but that's actually opened up our business quite a lot, because now we're making sure that there's no venue that people need to get together in. Opened up in Monaco. Currently, it's also in New York and Miami. So very, very happy to have done that so far. But what iCLUB will look like in the future is we want to add on to a couple more locations across the US as well, but also across the world, like in Dubai, the Emirates, in Spain, and in Switzerland, Cyprus, Azerbaijan, Kazakhstan, Saudi, and as well as Australia. So trying to cover quite basically the globe over there with iCLUB. So this is what our future planned iCLUBs are looking like. Our next one will be on the 14th of April. I believe that's just next week, Tuesday. Then we have London. So for those of you who are in London, we are probably going to be joining it up also with Monaco on the 16th of April. So that'll be pretty interesting as well.
Remove damage caused by getting old before it ever accumulated enough to make us sick.
Had articles written about you in the Economist. You've spoken at TEDx. You've been at Longevity Leaders, which is where all of the leaders from the world get together and talk about longevity and anti-aging and so on.
So I guess, rewinding all the way back, I decided relatively early that I wanted to spend my life studying the biology of aging. That came really from more of a philosophical orientation than a scientific one. Ideas for how we would address different, we call them now the hallmarks of aging, the different types of damage that accumulate in our bodies as we age. The first theories of how we were going to design treatments for each of those different things were kind of just coming out. And I thought that I was a generation too young to really be on the front lines of this, because I looked at this as a teenager and was like, oh, well, these things are all easy. So by the time that I finish my PhD studying any of them, the easy ones are all going to be done. So I have to spend my academic career taking the hardest problem that I possibly can. And so I took one problem that I was very passionate around, the idea of how do we engineer stem cells to be cancer-proof so that cells in our body can't develop into cancer, which was the most complicated of the 7 different ideas that were floated in the early 2000s for combating aging, and said that I was going to spend my PhD creating enabling technologies for that.
System. You managed to help people in universities and schools learn about how to grow cells or replicate cells using the DNA and replicating it in bacteria, similar to how insulin is grown for diabetics.
Exactly. Yeah. So this came out of kind of a twofold purpose. The first was that my younger brother and I both decided we were going to spend our life working on aging. We both knew that eventually if we made a discovery, we would want to turn that into a company, but we needed to know or wanted to learn early how you run a company, how you be entrepreneurial. Right. And so when he was a high schooler and I was a college student, we were like, well, we don't know shit about biotech yet. And so we can't start a drug company, but we do know something about the high school education system that I had just been through and that he was in at the time. And so we created an biotech education company that would teach young children or young high schoolers how to do genetic engineering.
Can you walk us through what we achieved over the last 100 years, where we are at now, and then what it is, what's our future?
Sure. If you go back 100 years, we have to remember that the average lifespan in 1900 was 32 years worldwide, 45 in the first world, 45 in the US. And it's because of increases in sanitation, increases in vaccinology and antibiotics, that we were able to pull that number from, let's say just in the US, from 45 up to 78 or so at the turn of the century, at 2000. But since the 1970s, when we really started thinking about, oh, could we cure cancer? Because before the 1970s, people didn't really try to cure cancer. They just allowed people with cancer to die. And in the 60s, before the 60s, we didn't really think about treating heart attacks in the way that we think about treating heart attacks now, because these four big diseases of aging have only been the major killers of humans for the last 75 years. And they've never been the major killers of humans for any time in our 100,000-year history before that. So our world has dramatically changed to be challenged by these diseases just in the last 75 years. And it's only been the last 40 that we've been really trying to knock at the door and see if we could figure out new ways to address them. An imbalance between our ability to degrade proteins, which is something that declines as we age, versus producing new proteins. And so you end up with aggregates because you have more proteins than you want and you're not degrading them. And you have an inflammatory environment because there are all of these stimuli sitting around in our brain that causes the brain to think it's infected by something when in fact it's just aging. And so if you can attack those things instead, upstream of the Alzheimer's symptoms, which I use symptoms in a molecular sense. The molecular symptom of Alzheimer's is amyloid beta plaques. And then you end up with what we call the phenotypic symptom of Alzheimer's, which is memory loss.
Which one of your companies is the closest to the commercial stage? And then we got Tina's question as well. Go ahead with the first one, yeah.
So probably of the companies I have under Cambrian right now, this Sensei cancer vaccine one is the closest to commercial stage. We'll be finishing our phase 2 trial by the end of this year. And then we would start a phase 3 trial if it works out at the beginning of next year, which means that would go onto the market in probably to be realistic, early 2022 would be that technology available for certain types of cancer on the market. And then we would begin starting more of the longevity studies if that finished its phase 3 study, thinking about using it as a prophylactic.
What's your opinion about stem cell treatments? Have those treatments been proven as safe and effective?
So when any of you have someone talk to you about stem cell therapies or stem cell treatments, those are almost always one specific type of stem cell treatment called MSCs, or mesenchymal stem cells. And there have so far been nearly zero trials that have convincingly showed that MSC transplants can be beneficial for any specific disease. And I want to caveat that with a couple of things. So the top line is no, it doesn't really work. But there's two caveats there. Number one is that anecdotally, when people do this, we see some people have really dramatic, very positive responses that you would not be able to expect in the absence of something happening with the biology there. But we just can't predict when it will happen, and it doesn't happen frequently enough to be statistically significant in clinical trials, right? There are things that we can do with mice and things that I've seen happen in humans that convince me there's something very, very exciting happening where stem cells can rejuvenate, but it's not reliable. And we haven't kind of nailed down how do we collect these cells, how do we culture and generate them to make them maximally therapeutic. It's an unanswered question. And number two is that there's clinical trial after clinical trial where you take someone who has, for example, shoulder or back pain, you give them an injection of stem cells, and they say, oh, this feels so much better, the pain in my shoulder has gone away, whatever. That's been done in clinical trial after clinical trial, and that's what kind of created a lot of the excitement about stem cell therapies about 10 years ago. But then people started to do placebo-controlled clinical trials where they would have people get an injection in their shoulder with stem cells in it versus just getting an injection in their shoulder that was just, water, salt solution. And in those cases, people also felt their shoulders got so much better. And so the when you had no injection versus an injection with stem cells versus an injection with just saline, the stem cells versus the saline gave about the same effect. So a lot of what comes out of this is a very, very strong placebo effect associated with the idea of stem cell treatments. Interestingly, we also see the same sort of effects with CBD and marijuana-based clinical trials.
Just like to say, James, thank you so much for being with us today, and spending this time with us and answering these questions and all of that. Ladies and gentlemen, this is James Peyer, PhD. He's been on The Economist TEDx Longevity Leaders, where leaders in longevity get together. It's lovely to have you here with us, and we couldn't be happier to have this event with you present, and all of you as well, all of the participants. I hope you learned something out of it. If you have any questions about iCLUB as well, what we're doing, what was this all about, why did we have James, etc., then you can also email me about that. And on that, thanks a lot, everyone. Enjoy your weekend, and I hope you all have a good one. Keep safe out there, and stay at home.